Hello. Today we will be discussing the Leetcode Problem 236, which is to find the lowest common ancestor of a binary tree. Here we have been given a binary tree with two nodes P and Q, and we need to find the lowest common ancestor. Now, when we talk about the lowest common ancestor, if we try to trace the path from the root node, which is in this case, 3, if we trace the path for the node P, it would be node 3 and then the node 5. Similarly, for the node Q, it would be node 3 and then the node 1. And if we try to find the common nodes in this both the paths, we have node 3 as the common node. And here in this particular example, we just have one node, and that is the least common node. But it could be possible that we have like few nodes, and let's say that there is a node 3, and then there is a node 5, and similarly, we have few common nodes, and then we have the node 1. Now all these nodes are common, but this is the least common node, and therefore this is our expected value. Now if we try to think about uh, how to find the lowest common ancestor, there could be two different scenarios. One could be that we have a node, and this node have a left subtree and the right subtree, and both the nodes P and Q are in different subtrees of this particular node. In that particular case, this node will be our LCA, because if we try to trace the path from this node till the node P, uh, all the nodes between this path won't be common in the path from the node till the node Q, and therefore the common node would be uh, the root node itself. In the other case, there could be like we have a node and we have a left subtree and a right subtree, and let's say both P and Q are in the same subtree. In that case, the lowest common ancestor would be the node which comes first in the path from the root node, in both the paths. I mean, if we have the root node, let's say R, from the node R till the node P, and from the node R till the node Q, whichever comes first would be our lowest common ancestor. In here, we will have P coming first before we come to the node Q, and therefore P would be the lowest common ancestor. Also, we can consider in this way that if we see all the nodes from the node R till the node P have common in both the path from R to Q as well as from the node R to P. And yeah, so we just need to take care of two things. Either both the P and Q are in different subtrees. In that case, LCA is our root node, or both the P and Q are in the same subtree. And in that case, whichever node is like comes first in the trace path, that is basically our LCA. Now the code for this one would be very simple. Let's say that we have an example. We have a function LCA, and it has a tree node called as we pass the tree itself, and then we have a tree node P, and we have a tree node Q, and it would return basically the tree node. And the first thing what we need to check is what if the root node is basically equal to null. In that case, so if the root node itself is null, then we just return the root node. And what if the other case could be the root node itself is the value P or the value Q? In that case, we would return the value P and value Q. So if root is equal to P, or if the root is equal to Q, then we would just return the value P and Q. So that's how we are doing here. So in this particular example, we from the root node, we travel into one of the subtrees and we visit the node which is either P or either Q. In this case, we travel first to the P node. Therefore, since we travel to the node P, we just return that back to the root node, and that is our lowest common ancestor. So that's what this if first if block would do. The next thing would be to make recursive calls. So what happened here is if we call this method LCA, we would first come to the if block. If the root is not equal to null and the root is not equal to P and Q, then we need to check the left and the right subtrees. So that is this particular example. So in this particular example, we came to the root node, root is not equal to null and root is not equal to P and Q. So we first go to the left subtree and then we will go to the right subtree to find the values. And if both the subtrees return not null values, then our LCA will be the node itself. And if any one of these subtrees return a null value, let's say for example, in this particular example, the right subtree would return a null value because we don't have any value over there, and both P and Q are in the left subtree. So the left subtree would return the node P, and the returned value, since one of the node returns null, we know that the whatever value is returned by the other subtree would be our uh, expected solution. So the recursive calls would look very simple. It will be root dot left comma p comma q. So we are just passing the new root, that is a left subtree's root node, and similarly the right subtree's root node, and both of them, let's say, would return us a node. Either it could be a null value or it could be a value of p and q. Now we will just add a simple check over here. So if left is equal to null, I mean, if left is not equal to null and right is also not equal to null, then as we discussed, if both are not null, then the root node itself is the um, LCA. Otherwise, we will check if left is equal to null. If left is null, then our solution is R, because R would return the value of P or Q. And if, let's say, our L is not null, then maybe the right subtree is null. So we will just return the left subtrees, whatever value is written by the left subtree. And that would be our solution. So yeah, that's pretty much it. It's a very simple problem, and I hope it was helpful. Please hit the like button if you found this video helpful, and I will see you next time. Thank you so much.